Hello everyone. Today we are going to solve problem 605 can place flower. So let's read what this problem is saying. So the problem is like this. The problem stating we have given a long flower bed in which some flowers are planted and some are not. And the flower cannot be planted in adjacent plots. What it means is saying we have a long flower bed and in some plots more flowers are planted and some plots are empty. And we cannot plant in adjacent plot. Like we can't plant two flower adjacent. We have to leave a empty plot then and plant new flower in next floor. So like something like this. And what's the thing saying? Okay, we have given a flower bed in form of array where zero representing empty and one means not empty. Okay, one means that plot are occupied means already flower are planted there, and zero representing that place is empty. And what we have to do, return true if n flower can be planted in the flower bed without violating the adjacent flower rule. Okay. So the problem is saying we have a flower bed and integer n. We have to plant in flowers in flower bed and we cannot plant two flower adjacent each other. So we have to return true if we can plant n flowers in the flower bed by considering this rule, not adjacent flower. And otherwise, return false if we can't. So let's understand this problem and how can we solve. So understand this problem. I have written some cases. Let's analyze this so that we can think better, like how we can approach it. See, a flower bed will look like this, where at index zero, a flower is planted and these plots are empty and here. And we have to plant and flower in this flower bed so that they are not adjacent. Two flower are not adjacent, and still we can plant a flower. So if I plant my flower here, then it will be adjacent. That is violating the rule. So I can't plant here. So I will move here, and here I can plant. Yeah, I can plant because in adjacent there is no other flower. So definitely I can plant here, and we have to plant only one flower. So in this case, I am able to do that. So I will return true. Let's analyze this problem. Here we have many empty plots, four empty plots, and we have to plant two flowers. Let's see how can we do that. If let's take one flower, can I plant here? No. Can I plant here? Yes, I can. Because there is no other flower adjacent to this, so I can plant here. Then I will move here. If I write here, then okay. If I plant here, so my n become now I have plant. I am able to plant one flower. So now my n become one. Can I plant that rest one flower? Let's see. Can I plant here? No. Can I plant here? No, because here is another flower already planted. So no. In this case, I'm not able to plant two flower. I can only plant one. So in this case, I will return false because I'm not able to plant two flower. Let's analyze this problem. Uh, let's make it normal like it was before where it was 0 and it was 2. Let's move to this case. Here we have how many empty plots? We have around 5 empty plots and we have to plant 2. So let's see, can I plant here? I can. I will leave this plot because I can't plant adjacent. So now I can plant here. Still, this one plot will be empty before this flower. So in this case, I am able to plant my two flower. Let's analyze this problem. Here we have 6 empty plots and we have to plant 3 flowers. So let's analyze. I can plant one flower here. I will remain two flowers. So I can plant another flower here. So till now I am able to plant two flowers. But now I have only two space and I can't flower my rest one because if I plant here, it will be adjacent to this. And if I plant here, it will be adjacent to this. That is violating my rule. So in this case, I am not able to plant 3 flower here. So in this case, I will return false. Here it was true because I was able to true. We had you again. Let's understand what's the pattern is going. So if I look carefully, so if I have two adjacent four consecutive empty floors, in that case I am not able to plant two. Why so? Because if I am planting one flower here, I will be left with the two consecutive ones, and in this case I can't plant one. If I want to plant flower, I need at least three consecutive uh, uh, zero. Why? If I take example here, uh, in this case, if I would have three consecutive zero empty floors, in that case, I am able to plant one flower here. If I have two empty flower, empty plots. In this case, I'm not able to plant any flower. So we need at least three empty flower consecutive empty plots to plant one flower. So in that case, I have four. Uh, so in that case, I can't plant two. Yeah, I can only plant one because left with only two consecutive ones. So I can't. But in this case, if I have five empty plots, if I have five consecutive empty plots, this is three, this is four, and this is one. If I have five consecutive empty plots, in that case, I'm able to plant two flower. How? One I can place here and one I can here. How? So I till now, if I understand it carefully, then it works here from mathematics working like this. If I have in case of 3, if I divide it by 2, it gives me 1. And and which case satisfies this one? 1, 0, 0, 0, 1. This case, let me move it here. So this satisfies this. If I have 3 consecutive 0, and if I divide it by 2, it will give me 1. About this one saying, this one telling that I can place one flower. Let's analyze another case. If I have 4 plants, then it's giving me 2, which is giving me false. I can't plant 2. So this is not working. But if I modify a little bit, instead of writing n by 2, what is my n here? No, let's call it m. Because n is our number of flowers. So let's call it m. M, what is m? If I write here, m is my consecutive zeros. Okay, consecutive zero. So if I have m zeros, consecutive zeros, so let's modify my problem something like this: m minus 1 divided by 2. Will it work? 3 minus 1 is 2. And if I divide by 2, it's still giving me 1. And here, if I divide by here, I have 4 consecutive, in this case, I have 4 consecutive flower bed. It means my n is 4. If I come here and I click right or something like this, my m is 4. And if I divide 1 from this, sorry, if I minus 1 from this, it becomes 3. And if I divide it by 2, it gave me 1. Isn't it? So in this case, if I have 4 consecutive empty floors, I can place one, and this is what in this case we have seen. If I have 4 consecutive floors, I can place only one, either here or here, not two. So this is working. Let's see with 5 consecutive floors. Again, my uh, equation will look like it is 5. After subtracting 1, it becomes 4. And if I divide by 2, it give me 2. This saying I can place 2. I can plant 2 flowers if I have 5 consecutive floors. Is it true? Yeah. In this case, when I have 5, 2, 2, 4. In this case, when I have 5 consecutive floors, I am able to place 2. So this is working. Again, if I take this example where I have 6 consecutive plants, 1, 2, 3, 4, 5, 6. I have 6 consecutive floors. In this case, I'm not able to place 3 because if I place one here and one here, I am left with 2, which is not uh, which is not working here because with 2 zeros, I can't place my plant. So, yeah, let's see this. If I have 6, but if I have 6 flowers, why I'm writing 2 here? And if I subtract 1 from 6, it becomes 5. And if I divide it by 2, it gives me again 2. What this 2 saying? With the 6 consecutive floors, empty floors, I can place 2 flower, which is 2 here. 2 in this case. I can place 2 flower, can't 3, but yeah, if I have 2, I can place. I can see my this formula is working for most of the problem. Now let's understand the edge cases. In edge cases, this is working when my zeros are in middle, like it is between 1 and 1 means it is middle. Let's understand some edge cases where my zeros are at the corner. In this case, I have only 0. Here we have discussed if I have to place 1 in middle, in that case, I need minimum 3 consecutive floors because with 2, if I cover this 0, then in with 2 floors, I can't plant my flower. But in this kind of situation, I can plant one flower here and still it will follow the rule. There will be an empty pot, and after that I can plant another plant. So here empty space, I'm able to place my one flower. So how this is working? So here we can understand that if I start my if I start my uh, why this working? Because after this, I have zero. Uh, in that case, I am able to place here. What if next this there is one? In this case, I have zero at my first index, index zero. But what if next is one? So in this case, I can't. So what we can understand is if I start from this place and this place is empty, empty means empty floor, and my next and my uh, and I minus one plot is empty, in that case I am able to plant my one flower. So here I have to plant two flower in this flower bed. Let's see, can I if I plant one flower here and one flower here, then yeah, I am able to plant my all the flowers, two flowers. Let's analyze this problem. In this case, can I? No, because here I can't plant because here is my another flower, another plot which is already planted. So I can't plant here. And here I can plant one. So in this case, I can only plant one flower, not two. So it will give me. Let's analyze this. This is starting. This is end. In this case, again, I can plant one flower here. And in this case, even if I two, still I can plant one, and if I three, still I can plant one flower. What is understood till now? So the logic will be work like this. I will start from if I take this example. If I take this example, so I will start not this. Uh, let's add one more geo here. Okay. So in this case, I will start from index 1. I will iterate over this flower bed. I will start from in I here, index 1. And I will check if my I minus 1 index is empty. In this case, I can plant one flower. So I can plant one flower. So here it become and it become and become one because I am able to plant one flower. So now I am left with one flower only. And I will move from here and I keep counting my zeros, consecutive zeros. And if I encounter one, then I will reset my count of zero. For example, if I try on this example, first at this place I have zero, then I will check if my I minus one place is also zero. In that case, I will subtract one from the n because I'm able to place one flower. And from here, I start counting the number of zeros. I will count one, and in next iteration, I will encounter one. So I will reset my zero count, and it becomes zero. So from here, I will recount, means count zero, and it will be one, two, three until appear one. So in when I encounter one, in that case, I will check how many counts I have checked till now. So my count is three in this case. So then how can I determine how many flower I can place using this consecutive plot? For this, I will use my formula m minus 1, which is m is found here. Count minus 1 divided by 2. This will give me how many flower I can place with this number of counts. And it will give me 3 minus 1, which is 2. And 2 divided by 2 will give me 1. So this tell me I can place one flower and I will subtract this count, this equation from my n. And when my n becomes 0 or less than 0, in that case, I will return to this saying, yeah, I'm able to plant my flower, otherwise I'm not. Again, let's check some problem and understand how I'm handling my edge cases. And for such this kind of problem, where I have two zeros, in such case, I will count here. At the end of the for loop, I will only count. I will not subtract one. I will simply do count by 2 n minus equal to a. Why? Because when I am doing this, then I am encounter one. But what one saying this is the this zeros belong from middle. And if I am not encountering anyone, then I will not go in else condition and I will directly come out from for loop. So in that case, I know that these count are uh, corner cases these are the edge cases. So in that case, I don't need to, in that case, I don't need three consecutive zeros. I can place, I can place a flower with two zero as well. What happened if two zero appear in middle? We have seen that if something is like this, in that case, we can't place one. Why? Because if I follow my formula, then my consecutive count is two. If I minus one from here and divide by two, it will become one divided by two, which is zero, which is saying I can't divide. So if my consecutive zero fall in middle, I will use this formula. And if my 1, 0, 0. And if my zeros are at the corner, at the end, in that case, I will use simply 2 by 2 equal to 1. In this formula, I will not subtract 1. Understood why, so? To handle this problem. This handling the last corner cases. And for starting, we can check. I will start from I and I will check if my I is 0 and my previous float is also empty. In that case, I can place one flower here. Otherwise, if my this is 1, then I can't place 1 here. So simply in that case, I will not check my previous float and I will keep moving. Hope so it makes sense. Let's code it so that we can understand more clearly. Let me just write one more example. What if I have only given this? In that case, I can place one flower definitely, isn't it? Because there is no any adjacent flowers. There is only one space which is empty. So in that case, I can return 1. And what if I have given this one? In that case, I cannot return any means I can't place any flower. So we have to manage this HS as well. So let's code it up, come to the editor and let's write it. What we need it first, what we have to return. Okay, we have to return boolean. Okay, so what things do we need? We need a count variable which count the zeros. So I will write zeros, G, zeros. Till now I have zero means zero now. Then I will write a for loop. I will run a for loop from in I equal to 1 to flower flower with flower where dot length till last, and I will keep moving index one by one. And here I will check if my flower bed if my if at index I, if it is 0, if at my index if there is no, if my index I it is 0, then I will check what I will check. I will check if my previous index is also empty. In case I will start from here. If my previous index is empty, in that case I can able to place one flower. Otherwise, I will not because there is one already flower is planted. So I just check flower where if if this also 0, then in that case I can check 1 because I know I can place one flower. So yeah. Otherwise, if it is not, if my first index is 0 or but last index is not 0, in that case I can't do anything. I just start counting my zeros. So I will count I will increase zero count by zeros by 1, isn't it? Okay, now this will run. What this if condition handling, if my power weight is 0, if it is 0, then it will work on, then in that case this for if condition will work. Otherwise, if my index is 1, in that case, for example, I will start here. Here my previous is not 1, not 0. So I start counting. It is 0, 1, 2, 3. And when I encounter this one, means I will fall in this else uh, block. So there I will check till this many 0, how many flower I can place. So here I simply what I can do, I can say how many flower I can place, and I will minus, I can minus the number of flower from this n. Simply here I can check zeros minus 1 divided by 2. This tells me how many uh, flower I can place with these consecutive zeros. And I will check if my n become less than equal to 0. In that case, I will return 2 because I have planted all n flowers. Otherwise, what I will do, I will reset my zeros from to 0 because I have encountered 1. So I have to restart my zeros again. So in that case, I will reset my zeros equal to 0. Okay. And from next iteration, if it will be 0, it will keep counting, keep counting. And at the end, it will tell me how many zeros I am able to, how many plants I am able to plot with this number of 0. But at the end, think this condition, if there is no 1 at the end, then I will never, uh, then I will never uh, go to this else block, and I cannot count number of, and I'm not able to perform this operation. So I have to manage this case outside of the for loop. Okay, so again I have to do this outside as well, because if my if there is no 1 at the end of the for loop, so I will never go in this else block. And here we have discussed that if it is the last, if it is the last corner, then in this case, with the 2 0, I am able to place one flower. So I will use this formula, not this one. So here I will not minus 1, I will only divide it by 0. And if it becomes less than 0, I will return 2. Otherwise, I will return false. This is my condition. Okay. So there is some flaws in this approach. No, we we are making a very silly mistake. This is only true when I started for the first time, like for such cases where my when I start from starting and from the first index and my index 0 is 0. In that case, I can place one flower. But here, what we are doing here, we are subtracting 1 for every index where the value is 0. For example, even if I am here and my previous is 0, in that case, I am subtracting 1 from the n, which is not correct. This condition is only applicable when I start from beginning, means for the corner cases. In in such cases, it is valid if I start from index 1 and if it is 0 and its previous index is also, if previous value is also 0, in that case, I can place one flower here. Not in every cases, even if I start here and if previous is 0, in that case, it is not valid. So I have to refactor my code little bit, and here I have to write something like this. If my I is only 1, in that case, you consider this case, if my index is 1 and if my previous is also 0, in that case I can place one flower and I will count 0 and I start counting 0 from the index first. So I will increase my zeros count by 1. And for the next time I will simply, after that I will not fall in this block because my I is not 1. So for other cases where my index is something else and if I still encountering 0, in that case I will simply keep increasing the variable count. For that, I have to write else if there is not a condition, then move to this block and write if my flower bed I equal to 0. So simply increase the zeros, zeros, zeros by 1. And if that is not also, if I encounter 1, so go to this block, else block, and check how with this many 0, how many flower I can place and subtract it from n. And if it becomes 0 or negative, then simply return true because I am able to place all the n. But otherwise, simply set my 0 to 0, my 0 counter to 0, because I have to count uh, again from the next block. Okay. And here we have discussed why I have written this like this, because this also handling the corner cases at last cases. So here, if it less than 0, return to, otherwise false. Come here and uh, handle edge cases as well that we have discussed. What if we have only, if my flower bed is less than 0, if my flower bed length is less than 2 or it is equal to 1, and not like this, and here, and flower bed equal to 0. If my at index 0, it is 0. In that case, I am able to place one flower here. I need to mention as well. If my n is 1 as well, in that case, return 2. Okay. Otherwise, if handle another case, if my flower bed is less than 2, but at index 0, I have 1 and I have have number of flowers more than one or more than one. In any case, either one, two, five. I can't place any flower in such case. So here simply return. Okay. So this case is handling situation where my flower bed is less than two. Otherwise, it will start from the index one and will follow the code. Let's run this. I have mistyped the flower beds and flower here also. Rerun. And yeah, test case is passing. Let's submit it to see whether it's working for all the test cases or not. Yeah, it's worked and it is quite better approach. Means it is giving good runtime. So yeah, this is working. Let's analyze the time complexity for this problem. So from here and understand what we have done. So what we are doing, we are iterating over this flower bed which is of length n or say m, and we are just running one for loop over this flower bed and keep counting the zeros and using a mathematic trick. We checking how many flowers we can place with this number of zeros. We are counting the zeros, and this is helping us to find out how many with how many zeros with this many zero how many flower we can place. We are uh, handling the edge cases as well. So yeah, this only takes constant linear time. So our time complexity is simply complexity. Let me choose the pen. Hmm. Time complexity is simply linear. Let's say m is the length of the flower bed, and the space complexity is constant. Why? Because we are not using any extra space. If I come to my code and show you, so here we are only using a zero variable and nothing else, no array, nothing. So simply it is a constant space. So the our time space complexity is constant and time complexity is linear.